I'm Anil Kumar sharing with you a test question on rational functions. The question is, for the rational function y equals to 3x minus 5 divided by x plus 5, state x-intercept, y-intercept, horizontal asymptote and vertical asymptote. You can pause the video, answer the question and then look into my suggestion. Let's begin by x-intercept. Now, what is the meaning of x-intercept? It is a point where the graph crosses x-axis, and at that point we know that y is equals to 0. So if I equate y equals to 0, I can find the x-intercept. So let me replace y with 0 and rewrite the equation. I get 0 equals to 3x minus 5 over x plus 5. Now, the rational function 3x minus 5 over x plus 5 can be 0 only if the numerator is 0. And therefore, we equate 3x minus 5 to 0 to find the value. So if you solve, you get 3x equals to 5 or x is equals to 5 over 3. And therefore, we can say that the x-intercept is at 5 over 3 and the y value is 0. So that is the x-intercept, right? So that becomes our answer. So x-intercept is 5 over 3, 0. Now let us find y-intercept. What is y-intercept? Y-intercept is a point where the graph crosses y-axis, and at that point x is 0. So we'll substitute x equals to 0 in our equation and then calculate. So that means y is equals to 3 times 0 minus 5 over 0 plus 5, and that is equals to minus 5 over plus 5, and that is equals to minus 1. So what do we get here is y equals to minus 1. So the y-intercept for us is indeed 0 minus 1. So that is the y-intercept, correct? So this is the calculation for y-intercept. Okay. Now let us find the horizontal asymptote. When the degree of numerator and denominator are same, horizontal asymptote is the ratio of the leading coefficients, which is 3 in this case. Well, straight away we can read the horizontal asymptote and we can write down our answer as horizontal asymptote is at y equals to 3. Now, algebraically, we can actually prove it also. What is horizontal asymptote? Horizontal asymptote is a position which the graph is about to reach when x is very, very large. So what we can do is, we can write this as, if I factor x, what do I get? So if I factor x from this equation, then I get x, and here I have 3 minus 5 over x, correct? And in the denominator, if I factor x, I get 1 plus 5 over x. Now if x is approaching infinity, a large value, let me take absolute x. It is approaching positive infinity or negative infinity. In that case, 5 over x or 5 over x will approach 0, right? If x is very large, 5 over x approaches 0. So what do we get here? What we get here is x times 3, because this approaches 0, so we'll neglect it, divided by x times 1, and x cancel, and we get the value of y equals to 3, right? So y equals to 3 becomes our horizontal asymptote. So that is the concept. So in such equation, that ratio gives us the horizontal asymptote, right? So that is this ratio. Now let's look into the vertical asymptote. So the equation given to us is y equals to 3x minus 5 over x plus 5. Vertical asymptote is when denominator is 0, correct? That is to say, we have to equate x plus 5 equals to 0, and that is 0 for x equals to minus 5. And therefore, x equals to minus 5 is the equation of vertical asymptote. So that is how you should be solving the question. So vertical asymptotes are when you equate this part to 0, right? So that is how you can see equation of a rational function which is in the form given. You can find that the horizontal asymptote is the ratio of the leading coefficients of numerator and denominator, and vertical asymptote is by equating the denominator to 0. I hope that helps. Thank you and all the best.